Alright, so the last thing we have to look at are these word problems. So we're going to start here with number 40. It says that a repairman leads the top of an 8 ladder against the top of a stone wall. So we're going to have our stone wall here, the ground there, and we're leaning an 8-foot ladder, it's a skinny ladder, to the top of the wall. So we know that this is 8 feet. The base of the ladder is 5.5 feet away from our wall. About how tall is the wall? So we're looking for how tall. So looking at this, we don't know any of our angle measures, so we're going to use the Pythagorean Theorem for this. Alright, so we're going to have our a squared plus b squared is equal to c squared, where c is our hypotenuse, which is squared on this side, and then x squared plus 5.5 squared. So 5.5 squared is going to be 30.2, and that equals 64, which is 8 squared. I'm going to subtract our 0.25 from both sides, and that's going to get x squared is equal to 30.75. Alright, and now in order to solve for x, I'm going to square both sides, and x is going to equal 5.809 feet tall. Alright, so that's number 40. So looking down at 41, it says, the 41, yep. It says that a square tablecloth has a line of embroidered flowers against its diagonal. So we have our tablecloth here, and then we have a line of flowers here. The tablecloth is 48 inches each side, so we know that this is 48 inches. How long is the line? So how long are the flowers there? So since we know that this is 48 inches also, and we know that all of the angles are 90. So that means if we split this in half to get that diagonal, we can bring out a triangle. Actually gonna be a 45-90 triangle. We're looking for x, and we know that our sides are 48 inches. So we can set up our ratio, which is 1 to 1 to square root of 2. And we know that these are 48 each. And we're looking for that diagonal. So in order to get there, we're going to multiply by the square root of 2. So it is going to equal 48 square root of 2 inches long. Alright, so that's number 41. Next, we're going to look at number 42. So number 42 says, a person is 40 feet away from a flagpole. So we have our flagpole here, we have 40 feet away, and we have a person standing. So this is going to be feet. And can see the top of the flagpole at a 35 elevation. So they're going to look up at this flagpole at 35 degrees. The person's eye level, so their eyes are right there, is 4 feet from the ground. So from here to here, their eyes to here is 4 feet. Alright. What is the height of the flagpole to the nearest foot? Okay, so we're looking for the, alright, so in order to find, so this is going to go all the way to the ground. This is the person's line of sight if they were just looking straight, so that's their horizontal line of sight, and then they looked up to see the top of the flagpole, so that gives us that. So if used trig, it would solve for this of our flagpole. But the flagpole has all the way down, so that's where that 4 foot comes in. So at the end, after we find our pink height, that means we have to add 4 feet to it in order to make it go all the way to the ground. Alright, so let's use some trig to find height. So we have H, O, and A, so looking at Katoa. We know that we are going to use O and A, which is tangent. So we have the tangent of 35 is equal to O over A, X over B. Alright, so we're going to multiply both sides by 40 in order to get X by itself. So X is going to equal at 40 times tangent of 35, which is 28. Point something something something, 0.0. So we're rounding to the nearest foot, means that would just be 2.0. Okay, so this is 28, but we're not done because this is just from the eye level up. So now, in order to get the height of flagpole, gonna be 28 feet plus the 4 feet, which is gonna get you 32 feet from that. Alright, and the last one we're gonna look at is 43, where it says an airplane is flying at the average angle 22 degrees at which the airplane must descend for landing. Alright, so the airplane here, let's draw an airplane. Airplane. Alright, and continue going straight, but then it's going to descend at 22 degrees. Alright, the airport, which is scheduled to, is 12,000 feet away. So from here to here, it is 12,000 feet away from the airport. Alright. Find the altitude. So our altitude is going to be is in the sky. And we're going to round to the nearest foot. So again, we're going to use SOHCAHTOA. Right now, our angle is not in the triangle. So we have to get it into the triangle by using alternate interior angles theorem. So if we have that 22 is here, we're also going to know this is 22 degrees here by the alternate interior angles theorem. Alright, so then we're going to label our triangle. So H, O, and A, which means we are going to use sine since we're looking at SOHCAHTOA up here. So let's see, we have sine of 22 is equal to O over H, which X over 12,000. We're going to multiply both sides by 12,000 in order to get the X by itself. Type that into the calculator, so 12,000 times the sine of 22 and get you 4,495 feet. 4,495 feet. Alright, so that's all for the review packet.